Hello. Hello, madam. Uh, shall we start?
Yes, sir.
Yes. Okay. Thank you. So, good evening, everyone. On behalf of Sanjay Godath Institute, Department of Computer Science and Engineering, I welcome you all on the day 3, session 1. So, today we honored to have Dr. Shilpa Gite ma'am, Bade Gite ma'am, who is currently serving as a professor at Symbiosis Institute of Technology, Pune. Madam holds the PhD in Computer Science and Engineering and has over 70 years of academic and research experience. Her area of expertise including artificial intelligence, machine learning, natural language processing, and data analytics. She has published multiple research papers in Scopus, 142 research Scopus Index article she has published and journals, has presented her work in reputed national and international conferences as well. Alongside academics, she has also been actively involved in the curriculum development, faculty training programs, and guiding postgraduate students in emerging technology as well. Dr. Geeta has delivered numerous expert talks and FDP sessions on AI and its application in education and research, making significant contribution to the academics and community. We are privileged to have her with us and we look forward to her valuable insight in this FDP. So I welcome Madam for this particular session. So without wasting any other time, I hand over this session to Dr. Geeta, Madam. Madam, please continue. Thank you.
Thank you, Sagar, sir. Is Let me know if you are able to see my screen.
Yes, Madam. Your screen is visible. No issue. Your screen is visible.
Okay. So thank you, Sagar, sir, and Sanjay Ghodawat University, and my old friend, Dr. Virat Giri. And I think this is for the second or third time I'm delivering Atal FDP for this college, but for other institutes, I have been delivering similar kind of sessions. So more specifically in terms of today's topic, where we see that there is a lot of potential of AI in education sector, and I really appreciate Sanjay Ghodawat University in order to finalize this topic, where we see that there is a need of, let's say, exclusivity in terms of students engagement. And with this line only, the topic that I'll be delivering is inclusive AI solutions in edtech. So just like Sagar has mentioned, myself Dr. Shilpa, and I'm working as professor at AML department at Symbiosis Institute of Technology, which is part of Symbiosis International Deemed University, Pune. I'm also associated as research faculty at Symbiosis Center for Applied AI, where we conduct AI and all allied and applied research with respect to various domains. So even in education sector, we have carried out extensive research work and also published our research work in good quality journal. So let's say here. Sagar, can you please confirm? Are you able to see my second
Yes, madam.
slide?
Yes. It's
Okay.
visible and properly audible as well.
Okay. Thank you. So we all know AI is everywhere. It is part of our day-to-day life, and we see that it has a huge potential of changing our life. So, with respect to that uh, goal of having AI everywhere in every sector of our life, we try to address AI potential and whatever things which are possible, like how we will be seeing AI's full potential in terms of healthcare sector, where we see that robots are there, where AI logic is used, intelligence is used, even in, let's say, banking, finance sector, AI is used, even for smart driving, it is being utilized. So each and every sector of our life is getting. Hello? Yes. Yes, is there any doubt? May I continue?
Yes, madam. Someone is
Okay.
accident.
Okay. With respect to bridging gaps in education, but making use of technology, it is a challenging thing because we still see that in the countries, developing countries like India, where we get free internet and all other stuff, we have now, with the help of Geo and other, let's say, platforms, where at each and every stage of our let's say small villages, we can still access internet. But still there are many sectors, or let's say worldwide also, we see that there is a huge gap in terms of reaching out good quality content using AI or maybe internet. And to keep all these things in mind, we see that the today's topic, that is inclusive AI, is very much needed. So it sees that how AI is catering to different needs of diverse learner sectors. So here diversity is not referring to let's say gender specific, so we will be also referring to continent specific, we will be also referring to the, let's say, economical class. So all such kind of inclusive aspects we will have to consider here in today's session. So it all about equitable access, right? So whatever content that we will be delivering or developing, it should be accessed everywhere and to every person. And at one point of time, whatever content that we will be developing or creating may not be a suitable fit for the learner, which may have different learning levels, right? So some of the learners will have, let's say, level of, let's say, 1 or 2. Some of the learners would be advanced learners. Some of the learner may have some cognitive disability, and because of which they are not able to get the simple concepts. So for them also some personalized or customization is required. So with all these abilities or disabilities or varieties, how we will be converting our AI in terms of reaching out to wider spectrum of the users. We also have the language barrier. Of course, I'll be discussing all these things in detail later on in my slide. But language barrier is like, we consider normally English is the most widely used language. But there are many more countries where English is not that prominently seen. They still stick to their native languages. So how we will be overcoming the language related barriers? So here, uh, today's topic will try to address different learning levels. It would also include the disabilities, it would also include gender wise spectrum, it would also include language wise spectrum, and SDG goals. So, Sustainable Development Goal, that is goal number 4, is all about quality and inclusive education for all. So, that is what with this FDP we will try to cater to, or may fulfill, try to somewhat part of SDG 4 goal. So, as per UNESCO report 2025, still there are 250 million plus children all across the world who are striving to get good quality education. And here, this is quite a shocking figure when we see that the countries like India are progressing, and now we have reached fourth position in terms of overall GDP. So we are progressing a lot, but still there are many more undeveloped countries who are striving to give good quality education. So here, what specifically inclusive AI means? So it talks about accessibility, where we see that there are diverse abilities of the users, or more specifically students. At the same time, we see that equitable parameters are thrown or delivered to the students. So here equity is referring to the fairness and bias, unbiased approach that we see. So AI, we normally categorize or would see the characteristic of good AI is unbiased data, or biasing is seen, let's say gender biasing. So even in AI context, if we train our machine learning or deep learning model with only one type of data, for example, only, let's say, medical context, if we are categorizing our data into cancerous and non-cancerous cells, and we are just showing, let's say, 100 images, total 100 images are there, and out of 100 images, 90 images are with non-cancerous and only 10 images with cancerous. So that way we are creating imbalance in the data set or bias in the data set. Even in terms of gender, if we are showing the images of a lady cooking in the kitchen every time and men playing football or maybe driving the car, so that is also kind of bias that we are creating. Maybe in terms of religion, we are training our system. Maybe in terms of our skin color, we are training our model, like if the person is fair, then there are higher chances of getting selected, or if the person is, let's say, having little bit darker tone, so there are less chances. So that kind of bias we are creating in our AI model, and that is what is required here in terms of training our AI model, which will be seen as a fair model or bias free model. Next aspect that we see in inclusive AI is all about personalization. So as per user requirement, the way our recommendation system normally work, right? For example, our let's say Netflix, or maybe let's say Spotify. So based on our earlier likings, our new set of information, so maybe a new song, new album, new movie, new web series, or new courses are suggested to us. So the way our recommendation system would work, so similarly, based on customized students requirement, some personalization is also seen as potential in inclusive AI for education sector. So it is basically to adapt to learners needs, skill set, the kind of content which he has covered so far, and also the speed. If the speed of the learner is slow, then accordingly new content is suggested to him. So likewise, that kind of customization is also possible here. And empowering, so how we can empower both the partners or ecosystem components in education. First one is student, but at the same time we should not neglect the teachers, who are very important, and they have the power to turn the youngster minds or students mind into very creative mindset or creative mindset. Okay, so that is what that empowering is also required, not only for student but also for teachers. And teachers should also get convinced that all these technological advancements are there to support the teachers but not to replace them. So that kind of phobia or fear, I mean, all other sectors are seeing, more specifically software is seeing huge decline in terms of hiring new, let's say, software developers, and we keep on hearing the news related to layoffs every day. So similarly, teaching is such a field that I would say, as of now, for next 20 or 30 years, these kind of technological advancements would not replace us as teacher. They would be, of course, there to support the teachers. Okay, so similarly, robots are there, but robots, they are not going to take each and every decision, let's say operation related or patient criticality related decision. They would be still there to support the doctor. So similarly, with the help of AI, teachers would get support, but these kind of technological things would hardly replace teachers. So we will have to remove that barrier from teachers mind also. So in general, I would say inclusive AI solutions in EdTech, they're basically about incorporating AI in such a way that it would ensure accessibility, equity. Equity is, just now we have discussed, it is all about fairness and bias-free approach. It also talks about customization or personalization based on learners' aspect, and in terms of their background, in terms of their, let's say, financial status, even in terms of circumstances, maybe some geographical hurdles. So here we keep on hearing the news like one country is fighting with another country. So that time also, even in our country, there are huge losses in terms of getting or giving free giving education on regular basis to the children, where normally in Jammu and Kashmir area where schools would be closed and there are some other issues. So at that location also our technology should be supporting even to that kind of geographical location where we see that there is a huge instability because of some or other political uh, connections. So accessibility we just now discussed. So with the help of AI in education sector, it would be also thinking about text to speech conversion, where if I'm not able to write or convert it into proper, let's say, English language, but still with the help of my, let's say, Marathi audio, I should be able to get the desired thing done with the help of technology, right? So even our voice assistant like Google, Siri, Alexa, all these are there. They would understand our natural language and would try to deliver the desired content. There are speech to text machines or technologies. There are image descriptions, like if I'm not at all aware about what kind of image it has, so I should be able to upload that image and should able to give the description or generate the description. Even we have already seen real time captioning, right? So if some of you would have AI background, where artificial neural networks, or more specifically LSTM, long short term memory, and recurrent neural networks, they are more specifically used in real time captioning, or let's say translation of language, let's say from Marathi to English, or let's say German to French. So all these real time translations are very much possible with the help of AI. So that is what accessibility related solution which is still there using AI. We also talk about multilingual support. So again, uh, with respect to different countries where they still try to stick on their native languages, the countries like, let's say, Korea, China, Japan, they are still into their native languages, right? Even European countries, they are still want to go for their native languages. So they may face, or some or other people or student would face the problem in terms of dealing with content which is available in their language. So AI is much there. Natural language processing related solutions, they are there to cater to all such needs. So be it regional need or be it, let's say, international language need. There are also researchers who are working more specifically, let's say, Sanskrit language, or let's say Pali language, or all other minority languages who are now rarely used in the communities. There are also screen readers which will have good compatibility with all other devices, and which will be supportive technological uh, uh, let's say, way which can be given to the students. Next thing is about personalization. So in earlier slide, I have given the example with respect to, let's say, recommendation system, which we normally see on, let's say, e-commerce site, where Amazon or let's say Flipkart, they would be suggesting you some or other product based on your earlier likings or earlier set of purchase history. So here also personalization for diverse learners. So here diverse learners would also have in terms of difficulty in learning. So the first point talks about student pace and style. So style is about learning style. Some of the student would like to just listen to the teachers, right? So only by listening they would get the concept. Some of the students, we see that they would be having more inclination towards video based or animation based learning. So there are multiple learning styles of the students, and they would also have their own pace with which they would get that concept. So in let's say at Symbiosis, we were given the training like there are different student levels and also different learning styles, and based on that we as a teacher should be adapting different pedagogical styles, so that some or other content would be delivered in different ways. So some of the lectures would be delivered in, let's say, flipped classroom, where one student would be coming and delivering and discussing some concept. One or maybe student group would come and deliver the concept. Another style would be like they should be exploring something on their own and then delivering the content. So likewise, there are different learning styles which can be adopted by the teacher. So that is how we'll cater to diverse learners skills and would deliver the content in effective manner. There are AI tutors or avatars which are available, and not only for normal student but also the students with dyslexia. I hope you can recall Amir Khan's movie Tare Zameen Par, and recently one more movie was there, that is Sitare Zameen Par. So based on different learning styles of the student, the AI module or AI teacher should be able to adopt new pedagogical ways, and then customization can be provided to the student. There are again different neurological disorders where which our AI is still seen as a feasible solution. Also there are cultural differences, right? And based on that, content would be recommended to the particular, let's say, student group, right? There are country wise some restrictions on the content, and we will have to, as AI user or maybe AI developer, we will have to adapt to that particular country's policy, and then we should be able to recommend that content to that particular student group. So likewise, every country has different set of norms, different set of restrictions. In some of the countries, WhatsApp is banned, Google Maps are banned. So based on that, country wise rules and regulations are also different, and based on that we should be able to come up with our customized or personalized AI based solutions. Third point talks about equity or fairness or biasness. So here, as AI is seen as the AI biased system, some of the times we see that the model that we have trained on the data itself has some kind of bias. That my bias maybe in terms of gender, maybe in terms of language, maybe in terms of skin color, maybe in terms of ethnicity, or maybe in terms of religion, right? So all such kind of biases should be avoided whenever the content would be developed and would be then delivered to the student. Then the point, very important point, is related to affordability. So we as developing country would always try to look forward for affordable AI solutions. So whatever comes with, let's say, some affordable aspect, easy to reach, easy to use, and pocket friendly solutions. And also there are some constraints with respect to bandwidth. So if you come up with, let's say, very high quality animation or video related effect, so that is also not a good thing for some of the geographical areas where still there are some internet issues. Third problem here, or third point here, is offline AI models for schools with limited internet access. The cities like, let's say, metro cities like Pune, Mumbai, or let's say be it Kolhapur, we don't have internet related problem, but still there are many more cities where we see that there is still limited internet access. And with the help of platforms like AI, where we see that internet has to be there, so how we should be coming up with affordable solution in terms of, let's say, less financial burden, let's say low bandwidth requirement, and even with limited internet access. So we will have to cater to all these needs and reach out to many more students. One more core principle of inclusivity talks about teacher empowerment. As we have already seen, and we keep on reading the news related to like AI would be replacing us very soon. We don't know for how long we can sustain. But here we will have to also train our teachers in a such a way that whatever solutions with the help of AI which are available, they are very much supportive. So, be it in terms of finding out student positive point or finding out student performance related things, like how he has progressed over the years. So, with the help of AI, good visualization tools, we can have all such things readily available, right? So, AI dashboards, they are very much there. Tools are there, so teacher can very well access the student performance. There are automated grading and feedback system with which teachers time can be saved. Earlier it was very monotonous process, but now with the help of AI and very good tools, we can get the things and all such kind of analysis very easily. Even for content creation, earlier we will have to manually sit and find out the content, which paper, which material, which websites are really good. But now with the help of very good AI tools, we can easily come up with our content which can be then very well and effectively delivered to the student. ChatGPT, Grok, and there are many more platforms which will help you, right? So teachers should be thinking about all these platforms as assistive platforms, not as potential threat who can replace them. Fifth point I would talk about is ethical and transparent AI. So, in medical field, more specifically, where we see that if let's say chest X-ray is being uploaded in our AI system, and that X-ray has been classified as cancerous one, so that kind of explanation is very much required, because a patient is not going to trust that particular AI system. So explanations are always required. So even here in education sector, if particular course is being recommended to a student, then that explanation must also be given. So explainable AI, and then let's say responsible AI, let's say interpretable AI, all these are very well discussed concepts in AI from past 6 to let's say 5 to 6 years. I have been seeing this explainable AI is getting very good attention, and that way we are going to make our systems very much trustworthy, right? Why trust will be developed with AI system? Because we are going to also give explanation, not only just recommendation, but also explanation why that particular system is recommending this kind of course to the student, or this kind of let's say revision session to the student. Then data privacy and consent related things, they are much there and very much required, because more specifically in India, if we see that our numbers are getting exchanged, our private data, our personal data, our personal email IDs, mobile numbers, each and every such kind of details are exposed to different agencies. So here, more specifically with respect to children related data, and that too, let's say children with disabilities or special needs, if such kind of data would be leaked, then there would be very much legal related aspects we will have to take care. So that is what data privacy and consent is very much required. If we are recording something, let's say be it video lecture, so consent is very much required, more specifically in case of children. Then policies. So India is still coming up with its AI policy for such kind of AI related aspect. So we are still referring to, let's say more specifically in healthcare sector, we refer to HIPAA compliant policy, which is given by USA, and also refer to European Union's policy, EUDR policy. But still, we are coming up with our own AI related policy for such kind of AI related frameworks. So likewise, there are many applications of AI in this field. First one talks about, let's say, assistive technology. So we will be always referring to AI as assistive technology. At the same time, uh, it should be customized as per user's requirement. Same time, we see that our system is able to find out behavior of a student. So I would like to also mention our project which we did during COVID time, where we have recorded students video. So those students would be my project group members kids only. So that is what, there was no question of consent. Otherwise, in order to record such kind of videos of other students or other kids is a problematic thing. So in COVID time, there were online lectures and we had recorded students videos while attending online sessions, right? तब तो schools online में चलते थे. So that time we developed a good data set and also find out AI related model where we could find out whether the student is not attentive or for how long student is paying attention to the teacher. And that is what very interesting research came out, where we can find out attention span of a student. So in normal case, I mean, if it is, let's say, offline lecture, it is like 20 minutes. So in 1 hour session, it is 20 minutes. And if it is online session, the attention span, more specifically in terms of children, decline to 8 minutes only. Only 8 minutes. So I'm also not sure for like how many are listening to me now, because this is online session, right? So more specifically with this behavior and emotional support, AI can be a good help. So behavior like student is distracted or paying attention or just keep on shuffling to different windows, so that thing can also be tracked. And on the same line, based on identification of behavior, our AI is much there to support the student emotionally. If our system is finding out that student is distracted, student is not paying attention, student is just closing his eyes, so that way these kind of flags would be made by the system, and we can then counsel the system, or the student, not system, sorry. So emotional support can also be provided, and we also, I mean, you might have also read to such kind of emotional AI related systems in education system. There are automated administrative tasks, right? So this is also possible, just like even for teachers, they would be utilized in order to plan the sessions effectively, in order to create the content, and also do the evaluation, also to suggest the content based on student performance. So even all such kind of things, AI can be used. Then enhanced accessibility, so that is there even for personalized learning. So based on, let's say, customization of student requirement and student performance, we can very well make it personalized learning experience. Are you all with me?
Yes, madam.
Okay, so far okay. I could see 214 participants are there. Okay, thank you. So in inclusive,
Good evening, ma'am. I have a question. Can
yes,
I ask now?
yeah, Pratiksha, bolo.
Behavioral support, is that successful in offline classes also?
Offline classes, I would say teacher is sufficient to find out behavior of a student. If I'm observing particular student, let's say for 3 or 4 months, so I would know that particular student would normally sit on this bench, would pay attention to me, but nowadays he's just looking here and there, or showing some displeasure or not paying attention. So we as human being are much capable to identify this behavior. But the AI related solutions, they will have to find out many more aspects. So not only visual aspect, right? So let's say in online classes, if the student is just looking like this, right?
Okay.
And we are just identifying that yes, student is paying attention to the screen, but we don't know what is going on in his mind, just ऐसा करके बैठा है. But at the
Okay.
same time, if we get to know other aspects, so other aspects as in multimodal aspects, so that is what in AI multimodal research is, I mean, it has become the buzzword. So not only video related gestures would give me full-fledged idea, but at the same time, if I get to know what kind of messages he just posting on his social media, right? But again, it is privacy related thing. So if I have access to his, let's say, social media related things, and I could see that even on social media, particular student is not seen as very, let's say, happy mood में नहीं है, थोड़ा सा depression में जा रहा है, even his audio related messages. So if I am asking some question to a student, and with the help of, let's say, audio tone, I see that the student is sounding very low, right? But उसमें भी हमको बहुत अच्छा उसका रिकॉर्ड चाहिए, पास्ट वाला. जैसे हम अपने मम्मी से बात करते हो, अपने आवाज से ही उसको पता चलता है कि आज तुम्हारी आवाज कम आ रही हो, क्या हो गया. So similarly, we should be having that kind of audio wala data of earlier days, right? जहाँ पे
Okay.
student has given his different mood wala things.
Like CCTV footage and all.
Yes, yes. So not
Okay.
only video, but audio, also let's say text messages, emojis, ये सारी चीजों को मिला के if we come up with very good, let's say, comprehensive वाला system, it would be seen as multimodal emotional AI.
Okay, ma'am. My second question is, as you said earlier, जहाँ internet access is low,
Hmm.
so can we apply AI over there also? Like flip classes, as you said, we
Hmm.
can organize flip classes. So we can हम कुछ ऐसा draw कर सकते हैं वहाँ pattern, so that that will help the students to entertain us, and we can entertain
Yes.
them easily
Yes.
and more effectively.
Yes, yes, yes. So that
Okay.
is what, but some of the part can be covered with low internet access because our focus is some AI based system. तो भले ही बहुत ज्यादा इंटरनेट की स्टेबिलिटी वहां पे नहीं होगी, तो बहुत हाई क्वालिटी अगर वीडियो डालेंगे उस एनिमेशन में और वो पर्टिकुलर एआई में, तो वो लैग रहेगा, तो स्टूडेंट वुड
Okay.
नॉट बी एबल टू एंजॉय. तो whoever developers of such systems are there, they should be considering कि there would be some geographical location जहाँ पे इतना stable internet connection नहीं होगा. Even in India, we see that there are many villages जहाँ पे तो electricity का भी problem है. तो वहां
Yes,
पे
ma'am.
क्या चलेगा, कैसे, how we can support? But still we should be having some kind of, let's say, backups or some
Yes, ma'am.
parallel alternatives where technology is still available to those kind of people.
Okay. Okay. Thank you, ma'am.
Okay, thank you, Pratiksha. So I'm happy that someone is listening to me.
Thank you, ma'am.
Okay, okay. So here I was discussing about the kind of application that are being utilized so far. So I wish to show you a small video of this Squirrel AI where personalized learning experience is given to the student. So I'm just sharing that window. Okay, are you able to? नहीं ना, दिख नहीं रहा है ना? I will have to again.
No, ma'am, it's not visualized.
Just give me one sec. So this Squirrel AI, अभी दिख रहा है?
Yes, ma'am.
I don't know आप ऑडियो सुन पाओगे क्या नहीं, but at
Future
least
of learning is here. Welcome to Squirrel AI, a
It's audible, ma'am.
tutoring system powered by cutting-edge artificial intelligence with content design and taught by award-winning teachers. Squirrel AI has already helped millions of students improve dramatically in math, reading, English, and science, raising test scores by an average of 25% in just one semester. This isn't traditional learning. This is personalized education on a whole new level. Here's how it works. At one of our state-of-the-art learning centers, your child begins with a brief diagnostic test on a Squirrel AI Smart Learning tablet. Unlike traditional tutoring services that rely on broad concepts and generic worksheets, our system breaks subjects into nanoscale learning objectives. For example, while a typical math textbook covers around 3,000 learning objectives, we've identified over 10,000, allowing us to identify and target the exact concepts hindering your child's progress. As learning begins, 2 to 3 minute videos led by master teachers break down complex concepts through interactive lessons, while in-person teaching assistants provide hands-on support. As your child progresses, our intelligent adaptive learning system continuously evolves, updating the curriculum in real time, adapting to their strengths, weaknesses, and learning style. But it goes beyond just academic improvement. Through its integrated MCM system, it also cultivates critical thinking, creativity, social emotional skills, and real-world problem-solving abilities, preparing your child for lifelong success. Meanwhile, parents can stay informed with 24/7 access to detailed learning analytics. With thousands of learning centers worldwide and rapid expansion underway, Squirrel AI is bringing this revolutionary experience to more locations every day. Discover how AI-powered intelligent education can help your child reach their full potential. Visit www.squirrelai.com today. The future of learning is
Okay, so this is the website. I'll be also sharing the PPTs later on, but still you can explore like how other countries are utilizing this. But again, this is with respect to the developed countries, but still there are many problems in countries like us or even let's say African countries. So I'm back again on the slide. Abhi dikh raha hai?
Yes, ma'am.
Application. Okay. So likewise, you will find there are many adaptive learning platforms. So some of the platforms are designed more specifically developed countries like USA or some of the European countries. There are also assistive technologies, just like I have discussed earlier. So those are more specifically, let's say, speech to text or image description related, or even braille. The language translation platform. So there are even many projects where we see that very effectively braille language can be utilized in order to carry out different tasks. There are also multiple language support which can be provided using AI translation tools. And the last point that we discussed is related to mental health tools. So again, related to mental health or emotional health, or let's say there are many projects of emotional AI. They would be referring to all the details, personalized details of students, where we will have to seek the ethical consent, ethical access and consent from the student. And if the student is less than 18 years, then parent consents are also required. So once we have these kind of data available with us, we can very well come up with mental health related app or tools developed using our advanced AI techniques. So there are many benefits, like we can improve the engagement of the students, right? So instead of just teaching particular concept in monotonous way, if we make use of videos, animation, or let's say some game based concepts, so it would increase the attentiveness and also student engagement during the classes. Time efficiency. So traditionally, if we used to let's say create one question paper and then would give the hard copy of the student, and then again teacher has to spend a lot of man-hours to correct those copies. So instead of that, if we have some, let's say, even we can very well make use of forms on Google or Team Quiz. So likewise, some kind of automated grading related tools, they are already there, but more specifically AI related things, where even for descriptive questions we still can have keywords related to that particular questions answer and get them graded, right? I know this is very difficult because it would also have the handwriting related aspect, because each and every student would have different handwriting styles, and there are many more constraints in this term, but still there are some good solutions which can be very well utilized in order to evaluate the students. Then inclusivity criteria, where we should be able to cater to the needs of all diverse learners. There are struggles in terms of identifying student performance. So if I'm having, let's say, 300 student in a class, so it is very difficult for me to find out what each and every student is performing, whether the percentage improvement is seen in semesters, in, let's say, in last, say, 6 semesters, whether particular student has performed well or not. So all such kind of analysis is now very much possible with the help of data driven tools. And also in terms of physical abilities or disabilities which are seen in terms of, let's say, physical, in terms of ear or visual abilities, there are different tools. So I would just give you glance of about all these available options. So this slide talks about some physical disabilities which particular student may have, but normally in our setup, typical Indian setup, we don't cater to such kind of students and their needs. But in developed countries or even in India, there are some special schools where students with physical abilities would be assisted and very well then educated via these kind of tools. So tools would include voice recognition software, then head tracking software, then eye tracking software. So all these solutions are much there in the market, but again, our target is some pocket friendly and, let's say, wider scale students. So that is what we normally in our typical education system, we don't look forward for such kind of assistive technology. But just to have an idea, I have put this slide. Another set of students may have, let's say, visual disabilities. So for them we can come up with, let's say, text to speech. So these kind of APIs are very much there, and any student can make use of these API and come up with the project where screen readers can be provided. And also for braille lipi, the displays can be provided. So TTS softwares are much there in the market. OCR softwares are there. Then audio descriptions for videos, they are also there. So these are the visual impairment related students who can benefit, who get benefited with the help of these technologies. Even for hearing related problems, we have these kind of solutions. So solutions like captioning. So if some of the student would face captioning related problem, then the solutions like YouTube captions, even we can uh, uh, change the speed even on our YouTube, increase or decrease the speed. There are speech to text related solutions which are there, transcription related services which are there in real time mode, but again good internet connectivity is required. There are visual alert systems which can be then provided to our students. So likewise there are many more such kind of technological supports which can be utilized for the problems. So one more problem is related to cognitive or some mental disability related problem, who would not get the normal content, just like we deal with our students in regular classroom. But some of the students would have cognitive problem, dyslexia and other. So for them, these kind of platforms are there. You can think about some gamification, you can think about some visual schedules, timers, maybe digital note taking and virtual assistants. uh, some of the inclusive AI solutions we see in terms of chatbots. So nowadays, for every website, so be it small website or be it established website, even if you just click it, on next second one chatbot would come, how can I help you? Likewise, that kind of chatbot support can be provided to learning platforms. Even LLMs nowadays, our students are developing softwares where LLM is provided to the student. So let's say one teacher has uploaded 100 PPTs, then PDF of 10 to 15 books. But now, as usual, student would get up 2 days before and would try to cover up all the concept in 2 days. So it is not possible for that student to go to those 100 set of PPTs and let's say 20 books. So for them, LLM can be developed. Even our students, they are already working on that project, where they could compile all the files which are uploaded by that teacher and would give the gist or maybe concise version. So even ChatGPT and all those solutions are much there nowadays to help the students. But that kind of adaptive approach is nowadays utilized by our student, and we see it as very good AI learning assistant for the student. So not only for student but also for the teachers. Then AI driven content translation, more specifically for regional accessibility. So here, some of the states, they would again have problem related to languages, right? Some of the state would not go for English, some of the state would not opt for Hindi, right? So for these, I'm just talking about Indian context, but again this is true for all other countries. So for them also, real time language or content translation, these are the solutions. Gamified AI platforms, so with them learning would be very much engaging for the student and would motivate the student to explore more. And early intervention system, where the system itself is able to find out that student is, let's say student has not logged that particular system yet, student is not able to complete even the first course. So these kind of notification, if we set up in the system, for example, I have given one online course, right? The Coursera, I mean, I'm just giving a random example. So I have suggested to complete one course on, let's say, one Coursera or Udemy or EDX kind of platform. So whether they have still started with the first lecture or completed 20 lectures, so all such kind of notifications I don't get. But if I come up with a system where I could see, like, out of 20, 50 students have logged, and then out of, let's say, 50, 10 students have completed, but there are still 20 students who are yet to click that link and log in. So if such kind of early detection system in terms of tracking inactive students, so that way I can find out those students and then would take early correction or action. Some of the best practices, maybe in terms of speech recognition, uh, then augmentative communication or speech therapy if it is required, if students are having some speaking disabilities, so for them also solutions can be provided. There are AI based translations, also web based learning platforms and online classes. So I think after COVID time only all these online platforms became very much popular, and they are much there in the market, they would be there. So all the students and even education system related stakeholders, they have identified the significance of web based learning, because we don't have, let's say, time, space, and even that much money to go and attend, let's say, IIT Chennai course. But still I can still access the course by having online classes. So that kind of distance related or geographical related barriers can easily be bridged with the help of all such platforms. So student who speak minority languages, still they can get AI translation related. And last point we have already discussed, we can still make use of augmented reality or metaverse related things in our teaching learning content. There are best practices for implementation, like we can find out specific set of students with different let's say preferences. So be it language preference, be it, let's say, some of the students can be identified as disabled students or some other special requirement. So this kind of need assessment we can do and come up with AI based solution based on their let's say problem, or based on their specific requirement. We can suggest a tool, so that way customization or recommendation would be given. Similarly, we can also train the educators who would get the insights about ethical AI. So I have already discussed explainable AI. So once we have explanation that can be given via our system becomes trustworthy, our system is seen as a responsible solution, and that way we see that our system is ethical system. Okay, so similar kind of trainings can also be given to the educators, right? So who are the what we can say building block for entire education system. So training to the educators is very much required here. And also there are some pilot programs which are run across in let's say IITs, so we can very well get the feedback from those pilot programs and then try to implement at small places also. And collaboration, communication, networking is very much required. So these kind of platforms may be very much required, wherein we can keep on sharing our experiences and best practices. But still there are challenges in terms of learning gaps. Some of the gaps are already discussed, like in terms of regions. So urban population, rural population, where we see that financial differences are there. So socio-economic disparities are there. Language related constraints are there, because we see that almost 7,000 plus languages are there globally. And in the education system, most of the content which is available is in English. So how we can still utilize or leverage the content which is available in English but now in Marathi, whether it is possible? So those kind of language barriers we should find out and come up with some feasible solutions. Then one more challenge here I see is limited teacher time and resources. In education system, we see that teacher has to manage all other stuff. So at least uh, in last 10 to 15 years, I have seen that the time I devote to teaching or preparation is 1/4. All other time is given to other activities like admin stuff. So this is true almost all other education sector. And at the same time our intake is increasing, so there is a lot of difference in terms of student teacher ratio. So how one teacher is sufficient, let's say, to find out need of 200 students? So this is not possible scenario, and this is one of the challenging aspect here. So that kind of personalization would be a challenging thing, because we have very less time in order to find out different needs of different students. And also special needs. So uh, uh, here in Pune, there are, I mean, as per my information, there are very few schools. If I see that there are, let's say, 1,000 schools for normal students, there are hardly 4 to 5 schools which will identify the need of these kind of special students with dyslexia and all other physical disabilities. So still there is a huge gap. And even if these schools are available, affordability is one of the prime aspect. Last point or last challenge I would see here is digital divide. So there are connectivity issues, rural and urban issues. Even there are not sufficient devices which are available, right? So even the tabs, even if government is coming up like free tabs can be given, free laptops can be given, but still in terms of devices which can be made available, or even the smartphones which can be made available to all the students in rural areas, that is a challenging thing. So we see that there is a huge digital divide, but over the years it would be resolved. Affordability gap and biasing and even accessibility gap. The aspect of data privacy I have already discussed. We should come up with unbiased AI related solution. Even the accessibility gaps, those can be resolved, and the educators can also be trained. So all such things are very much challenging, but still we are very much hopeful that with the help of AI we can still come up with solutions. So some of the actionable recommendations are like, if we can make use of AI and some robots. So now AI and robotics, like robot is just physical body and all the inside part is driven by AI. So here these are some of the statistics or some information, like how we can make use of AI tutors here. So Khan Academy is very much popular. So how they have adopted the model of AI and how their results are improved over the years. So they are very much fascinating. Even for the second part, where bridging equity gap for accessible tech use AI and low cost robots. So as per UNESCO, the percentage was low for earlier, but now the target is again by 2030, we are targeting almost 80% of global student by making use of this tech. So almost for such kind of actionable recommendation, there is a huge scope, and we see that government, all other governments, even other countries, they are very much supportive, because this is the sustainability development goal. Education for all, this is the basic right of every children to get good education. So that is why all other countries are now very much positive in terms of leveraging AI and providing feasible solutions all across to the globe. Another actionable recommendations, like empower teachers with AI and robotics tools. So here also, by the end of 2028, means in next 2-3 years, almost 50% teachers would get that AI and robotic literacy. So this is as per report of Education Next. Again, World Economic Forum, they are claiming that in next 4 years almost 70% graduate can collaborate with robots, right? So all such forecasting, if we see that there is a huge potential of AI robotics in education sector, and we all are very much positive in terms of incorporation of all these possible concepts in our day-to-day life. So these are some of the case studies. So Squirrel AI, I have already shown its video. So in Tunisia, there is app AI.
Ma'am, I have a question, ma'am.
हाँ प्रतीक्षा.
जो आपने earlier discuss किया actionable in AI. As you said earlier, by as a human being, we can decide by watching our class that how the mood is of any particular student. So
Yes.
if we in the AIs to evaluate the exam sheets, so as a human being, I can see and decide what the word is student trying to write, and I can evaluate by my own decision. How AI will help me regarding that?
AI as of now can, I mean, in order to have, let's say if we have developed something for quiz, it is very easy, 1, 2, 3, 4 options say. But even for descriptive questions, we can as of now just give the keywords, like let's say if it is definition, so these keywords should be there, or let's say in bulleted points. So if the student has mentioned out of, let's say, 4, only 2 keywords are seen, then 50% marks can be given. But again, as I have mentioned, this is very difficult thing to find out all these aspects manually. and even with the help of AI assistive thing, because each and every student would have different handwriting style. बहुत
Yes,
बार
ma'am.
हम खुद से गेस करते हैं कि स्टूडेंट को ऐसा बोलना था,
क्या लिखना चाह रहे? Yes,
क्या
ma'am. Yes, ma'am.
लिखना चाहते. बहुत
हाँ.
बार स्टूडेंट वुड गिव लाइक क्वेश्चन 1B का वो लिखते हैं कि 4B, बट
हाँ.
स्टिल बाय
We will
गिविंग
evaluate task for that question. Yes, ma'am.
yes. So this is very difficult part. Evaluation wala is still difficult part, but still with the help of some keywords we are trying to automate some of the part. Full fledged नहीं हो सकता है.
Suppose we will provide 2 or 3 keywords. If the student will make a grammatical mistake, then how AI will help that student?
सी ग्रामेटिकल मिस्टेक वाला जैसे हम गूगल पे डालते हैं तो वो ग्रामेटिकल मिस्टेक होगा तो अभी
Spell check कर रहे
ऑटो करेक्ट हो रहा है, ऑटो करेक्ट हो रहा है.
Okay.
तो वो
Okay.
कीवर्ड हमको बहुत केयरफुली देने पड़ेंगे. कभी कभी सिनोनिम्स भी रहते हैं उस चीज के, तो वो नहीं
Yes, ma'am.
आने चाहिए. बट गुड इज इन आवर टेक्निकल कम्युनिटी सिनोनिम्स नहीं रहते. कोई अगर रिकरेंट न्यूरल नेटवर्क है तो रिकरेंट ही चाहिए, उसका सिनोनिम नहीं होगा ऐसा. तो
As of a pharmacy student, is it considerable to provide keyword for the evaluation of descriptive type
yes.
questions?
Yes, but again it would be a debatable thing from students' point of view कि ये वाला keyword क्यों. At least in engineering we see that students fight for half mark. ये यहाँ पे क्यों नहीं दिया,
Yes,
यहाँ
ma'am.
पे क्यों दिया. तो it would be again very much relative thing, and by giving the rubrics, जैसे rubrics वाला कुछ चीज है तो we can very well incorporate in the module, right? बट फॉर डिस्क्रिप्टिव वाला कुछ चीज है तो वी नीड टू बी वेरी मच कॉशियस इन टर्म्स ऑफ आइडेंटिफाइंग द कीवर्ड्स कि क्या क्या पॉसिबल सेट ऑफ कीवर्ड्स हो सकते हैं, क्या क्या पॉसिबल आंसर्स हो सकते हैं, एंड देन अकॉर्डिंगली कम अप विद द सॉल्यूशन.
Okay. Thank you, ma'am.
Okay, so likewise there are many more case studies, so you can explore it later on. So as of now, the core inclusive AI solutions would be in terms of accessibility, in terms of personalized, or let's say user friendly or recommendation kind of content which can be given to a student, so it is considered as adaptive learning. Then teacher support in terms of smart dashboards, good visualization tools, and also to plan out few things, also to help the teachers in order to do some auto assessment. So assessment again, as discussed with Pratiksha, it will be a debatable thing because keywords and all others thing would be critical if it is descriptive.
Excuse me, madam.
Yes.
I have a query.
Yeah.
कीवर्ड्स के बारे में आप डिस्कस कर रहे हैं कि कीवर्ड स्पेसिफिक होने चाहिए. सपोज आई हैव टू लाइंस. देयर आर 2 वर्ड्स. लायन ईट्स मैन एंड मैन ईट्स लायन. Both 2 lines have 3 keywords, yes, and they are same. How the AI approach that?
So here natural language processing is there. So in natural language processing, there are 2 contexts, NLU, natural language understanding, and natural language generation. So these 2 concepts we will have to adapt in the solution itself, right? And that is what the ChatGPT, DeepSeek, and all other LLM, large language models, which are utilized, they would make use of all these keywords. So here the extensive concepts of natural language processing would be utilized. So not only keywords, but how exactly they are being framed, like just like you have given the example. So how they have used those keywords in the sentence. So that would also make the difference.
That's why I am querying this.
Yes. So not only keywords, but proper formation of the sentence with the help of natural language processing, NLP techniques. It can be also leveraged here.
My question is regarding the descriptive assessment through AI.
Yes. For descriptive assessment through AI, we will have to leverage full potential of natural language processing. Not only keywords, but there is a full-fledged AI pipeline which can be utilized to find out overall meaning of the sentence which student has written, and then accordingly marks can be allotted.
Okay, thank you.
Okay.
Hello, ma'am. Good evening.
Yes, sir.
Yeah, myself, Dr. R. Naresh.
Yes, sir.
I am working as assistant professor in the Department of Mechanical Engineering.
Okay.
I did my PhD in Mechanical Engineering in Thermal Engineering, ma'am. But
Okay.
now I am also pursuing AICT sponsored AIML PG certificate program.
Okay.
So very much looking forward to learn this AI and machine learning.
Yeah,
And
definitely.
so area of, I want to explore much knowledge in this area.
Okay, okay,
So
okay. Don't worry. I'm there. I'm going to also share my email ID on the last slide, so you can connect
okay,
with me later on.
sure, ma'am. So what is your suggestion to learn this AIML faster by working, because we are supposed to teach every day. Again,
Hmm.
we need to work. I'm already attending classes of this QIP every day.
Hmm.
But since we are very much different from this area, we are very much basic. We are beginners actually.
Hmm.
So,
Hmm.
what is your suggestions? Any resources you suggest to get more
Okay.
knowledge?
So for the non-AI learners, I would say it would take a lot of time because I have done my PhD in AI. That is what I know, all these things. But
Hmm.
you don't need to learn all the concepts in detail. You just have to think about how they are applicable. Only
Hmm.
applicability part you should be knowing.
Yes, yes, that is what I my next query actually.
Yes.
Actually, we would like to learn this AI in such a way that I can apply to my research area.
Hmm.
I can apply AI to my research area so that I can also do some good projects as well as publish some good research articles in this
Okay.
area.
Okay.
That is the idea. So can you please suggest what is the best way to
There are
go ahead?
many, yeah, there are many good resources. Maybe I'll share it with Sagar later on, and
Okay,
then
okay,
Sagar will be circulating. So you can go through all the links, resources. There are
okay,
good resources like Archive is the research paper where you
okay,
will get to learn all latest things which are happening in AI domain. So that way you will be keeping yourself updated and then
okay,
accordingly try to use it in your domain.
okay. So I'll also be in touch with you, ma'am. I will
Yeah,
write in an
surely.
email
Yeah,
to
yeah,
about
surely.
my queries.
Surely,
Thank you,
sir.
ma'am. Thank you very much.
Surely. Okay, okay. So since I have, let's say, 7 minutes now, so these are future trends like multimodal interfaces. The example which I discussed with Pratiksha, where we can very well make use of all gestures. So not only gestures, but all aspects via which data can be collated. So even for sentiment analysis, if voice, gesture, gaze based, all such kind of inputs, if it is given to a system, then it becomes multimodal problem. So this has got a huge potential. So if there are other researchers in the domain, you can also think about, don't just dependent on, let's say, tabular data and come up with your analysis. Try to get more insights. If some audio can be captured or some video of same thing can be captured or some other parameter, some other data can also be captured, so it becomes multimodal problem. So multimodal interfaces can also be developed. Then cost effective solution, as I have already discussed, they are very much required in the countries like India and many more. Then collaboration like UNESCO, and there are good organizations who keep on funding the countries like us or organizations in India for some or other kind of projects. So if we come up with good proposals, then we can definitely ask for funding from global agencies. With the help of generative AI, just like we make use of ChatGPT very extensively, we can come up with the textbook or content as per readers requirement. There are very good experiences, augmented reality or virtual reality related experiences that can be given to our students. And also AI mentors or AI tutors who will be working as, let's say, mentor for a student, and then customize the content accordingly based on student positive point and, let's say, weaknesses. So to conclude my topic, we will have to break the barriers. Just like our traditional mindset needs to be changed, we should be also think like how diverse users should utilize our system or should get the benefit, 100% benefit of the education sector. And even the person or the students with disabilities should also try to get 100% experience, learning experience from the content that would be developed. At the same time, the content which is developed or the system which are developed, they should be having a, let's say, gender related aspect, and also they should be considering socio economic related aspect. Of course, there are challenges which we have discussed in terms of digital divide, the biases that can be generated in the system knowingly or unknowingly, and data privacy related things. So we will have to develop system in a such a way that it becomes ethical, it becomes responsible, and it should be a collaborative AI system. So that way all the stakeholders, so be it educators, be it teachers, be, let's say, students, so all the stakeholders should be able to leverage full-fledged potential of AI in coming years. So with this line, I'm just showcasing my quote, that is, AI in education is not about replacing teachers but empowering them to reach every learner. So both the important stakeholders are covered here with this definition of UNESCO. Uh, these are the references which I have referred for today's session. And thank you so much. यहाँ पे नीचे I'm showcasing my email ID.
Thank
Hello,
you.
madam. I have a question.
Yes.
Madam, I am Anjali Tembronikar from Latur.
हाँ, बोला मैडम, बोलिए मैडम.
You presented the topic in a very simple and comprehensive manner. I like very much. My question is there any data available that shows that the graph of the quality of school children has improved over the year through the use of AI?
Yes, yes. There are reports which I was referring on Sunday while preparing this PPT. I'll be also sharing that link to Sagar. I refer to UNESCO's reports where they have seen that there is increase. Even the reports, अभी मैंने एक slide में दिखा था आपको. These things are showing. यहाँ पे actionable insights दिख रहे हैं आपको?
हाँ, दिख रहा है मैडम.
So here also that progression is seen, like how with the help of AI and robotics in education sector, the results are also increased, like student engagement is increased and all the stakeholders are benefited.
Okay. Thank you, madam. Thank you so much.
Thank you, ma'am.
Hello, ma'am.
Thank you, ma'am. The session was very effective, informative, and very nicely you have presented. Thank you so much, ma'am.
Thank you for attending.
Ma'am, another query.
Haan, sir.
Actually, I heard like when we put a query in ChatGPT, for simple query, it will give answers, right? So for giving that answer in the data center, so much heat is generated, it seems.
Yes.
And we need to go for cooling. I heard one query, one simple message,
Yes.
one question. It will consume 1 liter of bottle of water to cool that.
Yes,
that is what I
very
heard.
correct.
Is it
Correct.
true?
Yes, yes, yes. And that is
Then
now.
if there is a situation, so many people are using ChatGPT n number of times every day.
Yes.
So
Yes.
how this problem will be helpful? Whether AI is recommended in this situation, because we are speaking about sustainable development and sustainable
Yes.
energy, and we need to preserve the globe from this natural calamities. But when it is consuming huge amount of water and huge amount of cooling is required, how AI is recommended to be used by everyone? That is
Correct. Yeah. Yeah,
What
even
is your
school
call
children,
on this?
they keep on using ChatGPT for simple stuff. Even I have seen my daughter keeps on chatting with ChatGPT. What should I study? Whether I should study Marathi or science? Even these kind of
Yeah.
silly questions are also being answered by ChatGPT. So I do
Yes.
understand this problem, and nowadays it is being discussed amongst AI community, like how we should be still taking care of environment while advancing LLM, making use of all ChatGPT and the other stuff. So that is why the next solution or next wave which is coming up in AI is green AI. Okay,
Okay.
so green AI is all about, I mean, it is always recommended like if something is available with non-AI solution. For example, let's say robotic process automation. If something is or some task is getting automated with RPA without AI,
Mm-hmm.
then why
Okay.
to unnecessarily go for AI and make it like, yes, I have used AI, right? So similarly, if some of the algorithms are getting solved with the help of machine learning, then why to unnecessarily make it complicated and make use of GPUs and deep learning algorithms? So likewise, we will have to see alternate solutions. So even nowadays, instead of Python, which is the core of machine learning, or let's say AI, Python, instead of Python, people are now preferring traditional C or C++ languages, and that is what the computational difference also they have observed. So the trend is now moving towards green AI and sustainable AI. So
Okay.
thanks for
You're
coming this or discussing this topic.
so you're saying Python is dangerous than
uh,
CPP.
Not dangerous. This is very user friendly language. This is open source, so there are many Python communities. But at the same time, in Python also, how with less energy consumption or with taking care of, let's say, environment, we can come up with most optimized core. So that kind of work is also going on in the parallel way, that is green AI research work. So you can definitely explore this word, and maybe we can
Sure,
have a
madam.
discussion.
But green AI concept is looking good, but I think when everyone is allowed to use this chat GPT and AI tools, how
Hmm.
we can avoid this and how it will be helping, because we can't educate every person to go for green AI and they need to learn and they need to use
Yeah,
only
I
whenever it is
know.
required.
I know. It would take some time. So let's say we just keep on discussing global warming and other stuff, but still, I mean, we keep on using ACs and we don't take care of environment. So that kind of awareness, it would take some years.
Maybe what I'm saying is if it is not free, people will be using only whenever it is required.
Hmm.
Since everything is freely available, that may be one of the biggest reason
Correct,
which is
correct.
making everyone to use for silly reasons.
But these companies, they themselves have created free modules, and everyone is now encouraged. They are making use of it very effectively. So all other such kind of LLM platforms, they are gaining visibility. So it has
Yes, yes,
become a tech talk topic. So that
yes.
is what I mean. We should be thinking like whether I really need to make use of ChatGPT. So this kind of awareness should be created amongst users like us. I mean,
Mm.
we can start with us.
Okay, okay. Thank you, thank you. I will get back to you for any further queries
Yeah,
through
sure.
email. Thank you,
Sure,
madam. Thank
sure.
you. It was a nice talk. Thank you.
Thank you, sir. Thank you.
Hope so all queries are addressed by the madam. If still someone has a doubt or query, you can ask here or within the next 2 minutes, because our next session is scheduled right now on 7:30.
Hello, madam.
Yes, sir.
This is Dr. Shashidhar from Karnataka.
Ha, sir.
This is out of box question. I need your opinion in this regard. By using all these thing technological
Madam.
stuff, we are creating many confusions in the students' mind, because students who are good with academic, they will be managing these AI tools or the teaching methodologies what teachers will use using AI tools. But if see the average students are student with below average level of academic skills, they may be struggling with this new methodologies. What is your opinion about this, madam?
See, in every class, you would get such kind of students where they are very much pro to particular technological thing. So we will have to make them convince, and then maybe if that let's say student group is more, then accordingly you will have to reframe your module, teaching learning module. So based on diversity, and that is what today's topic is, like if there are students in my class which are in 100 numbers, so I should be taking care of not only major part, let's say 50 students, but what, let's say again 2-3 verticals can also be made, and based on that I should be able to cater to their needs. But here the challenge in our classes, like we don't have sufficient time to cater to all such needs.
Yes.
That
That
is
is one thing. And one more thing is the students are not so confident compared to that what we have learned during our college days. How much we are confident now, I am not observing such things in the student mind because students are confused with many things.
this is Gen Z ka problem, sir.
Yes.
And nowadays, I mean, almost every 10 years, the student generation is also changing. Some or other, and new set of problems they have. They are confused, just like you are mentioning. They are not paying attention. Their attention span, just like I have mentioned, it is just 8 minutes. Again, they keep on doing some or other stuff on their mobile or laptop. So these are very common problem, and they are being observed in past. Let's say, I think post COVID, it has triggered a lot.
Yes, definitely. Thank you.
Hope so. Now all queries are addressed. So here we are completing the session. So thank you very much, ma'am, for delivering this insightful session on the inclusive AI solution. Your talk beautifully highlighted how artificial intelligence can break the barriers in the education, make learning more accessible, personalized, and inclusive for the students with the diverse needs. So on the behalf of Computer Science and Engineering Department of Sanjay Gauda Institute, I thank you very much for delivering this exciteful session. Thank you so much, ma'am.
Thank you, sir. Okay. So I would be taking your leave.
Yes, madam. Yes, ma'am. You may leave.
So I'll be sharing today's content and also the material which is asked by 1 or 2 participants.
Yes, madam. Yes. So the next session, I just invite my colleague, Miss Shubhangi Patil, madam, to introduce our next expert, Miss Shubhangi Patil, madam.
Okay, sir. Thank you. Good evening, everyone. Am I audible, sir?
Yes, you are audible, ma'am.
Okay. Good evening, everyone. On behalf of the Department of Computer Science and Engineering, Sanjay Gauda Institute, I welcome you all for third day, second session of AICT Atal FDP on empowering educators with AI in teaching and research. Today we have with us Dr. Shruti Patil ma'am. She's an enthusiastic academician and an avid researcher in the field of artificial intelligence and machine learning. She's a gold medalist in BTech Computer Science and a GATE qualified. She has been an industry professional in the past, currently associated with Symbiosis Institute of Technology as head AIML department, associate professor, and with SCAAI Research Lab as a research associate. Her research areas include applied artificial intelligence, natural language processing, caustic AI, adversarial machine learning, data privacy, digital twin applications, GANs, multimodal data analysis, and responsible AI. She is currently working in the application domains of healthcare, Industry 4.0, service under which she is also guiding several UG, PG, and PhD students as a domain expert. 4 students have successfully completed their PhD under her guideship. She has published 120 plus research articles in the reputed international conferences and Scopus Index journals. Dr. Shruti Patil ma'am has also invited to deliver talks related with her expertise in various prestigious institutions, international conferences, and industry summits. She is also working as an advisory board member in various universities for AI program management and as an AI consultant in IT industries for AI research projects and curriculum design. We are delighted to have her with us, and I now invite Dr. Shruti Patil ma'am to take over the session. Hello, ma'am.
Yeah. I hope I'm audible and visible as well. So
Yes,
warm good evening to all the participants for this Atal FDP, and thankful to the team of Sanjay Ghodawat for making it possible so that we can come and interact with all the AI enthusiasts who are ready to dive into various technicalities of AI adoption. So just now, Dr. Geete has presented a very nice topic about, adoption of AI into education. I'm going to delve into a little bit more technical aspect of AI, where we are going to see what are the advanced machine learning styles which are available in AI. It is not only about applying supervised or unsupervised learning, but there are many different learning styles which are available, and how we can use those styles, and a comparative analysis between what kind of problem is there and what kind of learning styles can be applied. By today's presentation, the faculty members who are already working in AI will get many new research directions, where they will be able to apply a permutation and combination of these various learning styles, and that will open up lot many areas, lot many possibilities for novel AI research work contribution for all of you. So let me just share my screen. I hope my screen is visible to all.
Yes, madam, it's visible.
Yes. So quickly, we will start with today's topic about machine learning styles. And especially, I'm going to talk about advanced machine learning styles with all the participants. And I assume that, many of you are knowing the idea of basic three machine learning styles, which is supervised, unsupervised, and reinforcement learning. Today, we are going to, dive much more deeper into these learning styles. So if you see nowadays, the AI usage has not only been, the discriminative uses of AI, where we used to analyze the historical data and give the predictions based on that data. But along with that, lots of generative uses of AI has also came into the picture with the advent of various large language models, and especially it has started with transformers, and from transformers we have shifted to large language models as well, where AI not only has now the capability of analyzing the historical data, but it also has the capacity to generate the new data, right? The data which might be present in the historical records, or the insights from those data which it can generate, and something which is not available on the internet all the time. So they are not the tools who only do copy pasting of data, but they are the tools who are analyzing the historical data and generating the new data at one point of time. So if we see, various AI models now have moved from not only data understanding, but they are understanding the data as well as generating the data. Both the capabilities are equally used in various, say, domain areas, be it healthcare, be it, I would say, finance, be it insurance, be it law, or be it AI e-governance as well, right? Now, if we see the application layers of AI, so generally, the infrastructure layer has all the machine learning algorithms which are deployed. There is an AI framework, there is a storage and computing facility, and the data which is available. And above that, now we have two layers, out of which the middle layer is the one which is the most important one, where we take the decision making layer, where the cognitive analysis of all the insights is done, and then these ability of, what I would say, intelligence is integrated into various application layers, such as in AI plus daily life applications, or AI plus social governance, or AI plus cyberspace. But in all these applications, all of you, if all of you can, all of you have seen it, it is like the input data is almost similar, right? Either it can be a textual data, or it can be an image based data, or it can be an audio based data, or it can be a numeric based data, right? So what can be an examples of this? For example, if I want to interact with Siri, and I want Siri to use her intelligence as well. So what it is nothing but a text to speech applications, but then in the back end it is also using natural language processing. It is taking out the insights from various internet sources, and then again converting it into, from text to audio back. right? So these kind of multimodal applications are the ones which are maximally come, right? And even the basic data, which is for example image based data. So if I want to detect whether a person has some kind of lung diseases or not, so in that case if I'm looking at their x-rays, so this data slowly has also become very complex. Why? Because day by day the diseases are also becoming very very complex. So the way we used to analyze those x-rays 10 years back has definitely changed now when we want to analyze the chest x-ray of a normal person, right? So what has happened over the years, the complexity of the data has also changed. The presentation level of the data has also changed, as well as the volume of the data has also changed, right? But with AI advent, we were initially using only supervised machine learning or unsupervised machine learning. These were the two main learning styles which were available. But since there is so much of complexity in the data which has come, of course, we also have to change the way AI models are learning. Now, this example is very similar to way humans are learning, right? For example, the way we used to learn in the school 10 year back and now the way our kids are learning, so that learning pattern has changed, that learning style has changed, right? And when we say that it is artificial intelligence, so we learn by experience, right? So when we are giving this artificial intelligence to our machines as well, they are also going to learn by experience, correct? But that experience is given to those machines via data sets. But now slowly day by day, since my data set is also becoming more complex, so because of that reason the way machines are learning from that data also needs to be changed. And this is the reason why now we are moving towards usage of more advanced machine learning methodologies, or advanced machine learning styles as compared to your normal styles. Now, if we see the brief history of AI with deep learning, now we have reached till here, which is 2020 onwards. We are on transformers, chat GPT, and moving ahead now towards AGI as well, which is artificial general intelligence. So these machine learning styles, however, were present from very very start, okay? But somehow initially, since we had lots of labeled data with us, so we started using supervised machine learning. Then we realized that there is some amount of unlabeled data also available, so we moved towards unsupervised machine learning as well. But slowly we have came into an era where labeling the data, it's slowly becoming very very less, and we are moving towards such kind of AI where without labels also AI will be able to learn the insights and will be able to give us the predictions or the required generated data. So since now there is that need of reducing the dependence on the unlabeled data, or sorry, on the labeled data, various machine learning styles have came into the picture. So there are various advances in AI techniques which has happened very very recently. So be it adversarial machine learning, which tells about making AI systems more robust, or be it graph neural networks, which is nothing but to make AI learn from graph based data, because there is lots of linking within the data which is available, and it will become easier if that data is arranged in the form of graphs, and AI will be able to learn from that graph. Then one of the advances is this, on which we are going to talk a lot, which is miscellaneous machine learning styles, which is about adopting new ways of AI system learning from the environment. Of course, there are rest of all the advances also which are available, such as explainable AI now slowly is becoming a compulsory norm when we are implementing the AI systems at the commercial level. Or be it responsible AI, very very important advancement which is currently going on, where we are making sure that our AIML systems which we are developing for very crucial applications are actually trustworthy. So basically all these three components are related to each other: adversarial machine learning, explainable AI, and responsible AI. All these three are something which are related to each other, If I add explainable AI and if I make my AI/ML systems more robust, automatically I'm achieving a responsible AI system, right? So all three of them are that way connected to each other. Then multimodal AI systems are also coming into the picture a lot. So nowadays, very few applications we will find where the input data is only image, or where the input data is only text, or maybe the input data is only audio. The critical problems which currently AI we are using to solve are such systems where multiple modality analysis has to be done. So in one go I have to analyze the image data also, and of the same patient I have to maybe analyze the lab reports also, which are written in text. And in those reports I have a text data also, I have numeric data also. So there are multiple formats of the data which are available, which I have to analyze them together, so that then the actual insights or actual outputs will simulate the human decision making power. Because whenever we are taking any decisions, at that point of time we are not taking it based on one modality, we are considering all the various modalities for this purpose. Then we also have domain adaptation, which is again one more very advanced techniques where we try to compensate for the scarcity of data. Then we have transformers and language models. And finally, quantum computing is also coming up very, very fast. And definitely lots of research and lots of capacity building has to be done in quantum computing as well. Now these machine learning styles, what they do in my AI/ML application. So these ML styles basically designs the methodology via which our AI/ML algorithm is going to interact with the data. It's going to learn the patterns from the data, as well as is going to understand the labels which are available in my data set, and also going to understand the feedback, right? And these machine learning styles are not meant for one generic problem, right? Like for example, any AML problem, if I am applying supervised machine learning, that is not correct, right? Supervised machine learning generally has to be applied for the problems where the data set has already a labeled data set, and they are basically a limited data set. Then only supervised machine learning will fit very properly there. But if I have scarcity of data, if I do not have labels to my data, right, if there is lots of unbalanced in the samples which are there in my data set, then in that case of course I have to choose another machine learning style. So no need that we have to make our AI/ML algorithm learn from the data in one way, right, or in one style. There are many many ways and styles which are available, which all of you should definitely explore, right? So now each style has basically arose to solve specific pain points in the real world ML development, right? When we realize that the data is scarce, a new machine learning style has came into the picture. When we realize that not always from labels we can learn, maybe from environment also we can learn, then reinforcement learning came into the picture, right? Then for example, if I have lots of metadata which is available and I wanted to learn from that metadata, so meta learning came into the picture. So every new problem which came into effective learning of ML algorithms, a new machine learning style has been utilized. But it is not so that these machine learning styles were not available since long. These machine learning styles were available from the time when AIML concept was coined, and the application started on AI. However, since now we have so much of complexity in the data, because of that reason these machine learning styles have came into the picture more now. However, they have been proposed very very long time back. So but why now, right? So this is the main reason that why are we using these new type of machine learning styles now. Because now we are facing lots of issue regarding the data set. It has become very difficult for us to label the data. So labeling bottlenecks are many, especially where are those bottlenecks. For the applications which are related to healthcare, there are lots of labeling bottlenecks, right? Then there is an explosion of unlabeled data. If for example I want to analyze the social media data and I want to find out the way, various countries have responded to various kind of disaster calamities which are happening in various areas in those countries, of course I need to analyze the entire social media data, right? If I take even one social media data, for example Twitter, if I want to analyze that how each and every government of various countries are giving response to this, there are more than 10,000 million tweets regarding this one topic, right? And labeling this manually is almost impossible. We can't label that data. So this way there has been an immense explosion to unlabeled data. There are also transfer across task and domain. So for example, all of you might have seen lot many AIML solutions for finding out fake news detection, right? But there are very less AIML systems or models which are available to find out fake news in beauty misinformation or in beauty information which is available on social media. So there is lots of beauty related fake news also which is present on the social media, right? If you apply Vicks you will have weight loss, if you apply soda you will have whitening. So, and these kind of news are very well followed by younger generation, which are not authenticated by any doctor, right? So in this case I have lots of annotated data sets available for fake political news data, but I do not have any data set which is available for beauty fake data. So in this case also we have to do transfer learning across tasks or across domains. There also these machine learning styles are very important. Then need for generalization and real world deployment. Of course, for more generalized AIML models, currently supervised or unsupervised machine learning algorithms are not performing that great. And then desire to mimic the human intelligence, because of course we as humans are not learning things in one way, right? For every given problem we also utilize various ways, right? For example, if I have only one day to study for my exam, my pattern of learning will be very different as compared to if I have 1 year for my exam, correct? So since we want to mimic the human intelligence, so we are also mimicking various human learning styles as well in AI. And again, no one size fits all, so this is the reason why various machine learning styles have came into the picture. Now, if we do a comparative analysis about various machine learning styles, what is their strength and where, traditional machine learning styles, which is supervised or unsupervised machine learning or semi-supervised machine learning, is falling short. Okay, so if you see supervised machine learning, if we take, then it has a high accuracy only with lots of labeled data, but it is failing when we need a large label data set because we can't manually label those data sets, right? If you take reinforcement learning, so it basically learns only via the framework, only via the environment where we develop the reinforcement learning agents, and those agents will learn via the environment. But if I have some static label in that environment, it will not be able to learn from that, right? Then few shot learning. Few shot learning is a kind of learning that you can apply in various problem statements where you know that the available data set is not big, and even in that data set for every class I have very few examples or very few samples available with me, then few shot learning works very well. However, traditional machine learning falls short, because traditional machine learning do not give good accuracy with limited data, whereas few shot learning can give very good accuracy even with the limited data, right? Similarly, in meta learning, it is a kind of learning where, for example, I know a kind of sports, okay, I know football very well, okay, then if I want to also learn basketball, since I know football, my learning of basketball will become faster. Why? Because I already have some kind of metadata on which my brain is already trained, that if I know how to play a ball game which is named as football. So basketball, if I want to play, some or the more rules will be similar, the ground will be similar, I know how my reflexes are going to work. So meta learning is about that if my model already is trained on one task, for the next similar task my model will adopt very fast. Now this is also not possible in my traditional machine learning models, where traditional machine learning has to retrain from scratch, whereas in meta learning the initial learning weights are also preserved and then the new learning weights are also given to the model, right? Then we have a self supervised learning. So it basically uses an unlabeled data very efficiently because it ensures that the model is learning on its own from the unlabeled data rather than having a dependency on the labeled data. So this also is not possible by your traditional machine learning models. In multitask learning, it is very similar to mummies at our home, where they do huge amount of multitask in one time. So in this case, what happens is even the AI model is trained to do multiple task learning in one go rather than doing one task at a time. This is also not possible by your traditional machine learning, like supervised or unsupervised or semi supervised cannot do multitask learning. And last one is federated or a co-learning, where we basically make sure that even though the learning is happening in distributed environment. For example, we have an HDFC Bank. HDFC Bank is in Bombay. HDFC Bank is in Pune. HDFC Bank is in Chennai. But all of them are using, machine learning models to find out that what is the chances that this particular client will be taking our premium policies. Okay, so to do this prediction, of course HDFC Pune branch is also running a machine learning model. Chennai is also running, Bombay is also running in this way, correct? But ultimately what is going to happen, that all of them belong to one organization, which is SDFC as a central organization. So in this case, which means what I'm doing, I am running sub machine learning models at all these locations, and ultimately the outcome from these machine learning models is also getting collated at one central place, at one main machine learning model which is there, and based on that they are giving me the prediction. So when we apply machine learning in a distributed manner, we say that we are using federated learning. However, all these models, the model which is at Chennai, the model which is at Pune, the model which is at Bombay, they have to make sure that they are doing coordinated learning with each other, right? So because of this reason, this is also a new kind of learning which is available, which generally supervised or semi supervised learning would not be able to do a distributed learning in this manner. So these are the basic strength of all these different kind of machine learning styles as compared to your traditional machine learning styles. Now, how to choose a machine learning style? So that would depend upon, so whether I have to apply multitask learning, or I have to apply a meta learning, or I have to apply few shot learning. So the choice of machine learning, if I'm not using a traditional machine learning style, which is supervised or unsupervised, it was very easy for us, right? That if it is a labeled data set, I can use supervised machine learning. If it is a non-labeled data set, I can use unsupervised learning. But given now there are so many styles which are available, how to make sure that I'm using the right kind of new machine learning style, that will depend upon what data is available to you, what kind of, first is actually what kind of problem you're trying to solve using AI, right? Then what are the I would say parameters of your data set, what is the size of the data set, then is it labeled or unlabeled data set, then per class how many samples are available in that data set, right? What is the confidentiality level of that data, right? What is the complexity of the task, what the AML model has to do with that data, correct? So all these things matter. So how is my data availability, is what is the labeling cost, how are my adaptability needs, how complex is my task. Based on all this, then we can decide whether I have to use meta learning, or I have to use co-learning, or I have to use reinforcement learning, right? So as an AIML researcher, whenever you have a problem at hand, the first thing that matters is how you are doing requirement gathering for the given problem statement, right? Are you understanding the problem statement very well? Then also deciding whether does a solution to this problem really require AI, then only we have to apply AI, right? Once the answer to this question is yes, then you have to decide that okay, then what kind of machine learning algorithm I have to implement, what kind of style I have to implement. Then you will come to these questions, and based on this, based on the data availability, you can decide the kind of AIML framework that you want to implement, right? So the initial three steps are the major steps to decide the success of any AIML project. First is understanding the problem very well. Second is understanding the role of AI into that solution very well. Third is understanding your data very well. And then fourth is choosing the right AIML framework to implement the solution, right? Once this is done, then the implementation or coding is just 20-25% of the overall part or overall effort that we are implementing for solving any problem statement using AI. So if you see the taxonomy of various machine learning styles, so in supervise also we have various learning styles. So these are nothing but the sub styles which has came out of the base of supervised machine learning, right? So be it meta learning or multitask learning or active learning. Then in unsupervised we have self supervised learning, which has come as a advancement of unsupervised. We have association rule learning or constructive learning, and we also have reinforcement learning. There are many hybrid styles also which are available, such as feature learning. So generally in multimodal AI we try to do feature fusion, and then we learn from those mixed features which are available, or semi supervised learning. Or advanced styles, if you see, then there are co-learning or few shot learning, ensemble learning, which is already available since long, or transfer learning or federated learning. These all are also advanced styles. So from this one slide itself, all of you can come up with 20 different machine learning based solutions for various problem statements. Nowadays what is happening, when we apply a traditional machine learning style to an application area, and if you write a paper and submit it, the first question is asked is what is the novelty, what different you have done, right? So in this case, to do some novel innovative work in AIML, definitely application of these machine learning styles instead of traditional machine learning styles are definitely going to be more useful for all of you. So we have done some research. I have published a paper on machine learning styles with one of my PhD student. So we have seen that what is the publication per style which are available. So if you see, we have taken the data from 2015 till 2022. Now I would be upgrading it to 2025. I'm sure the graph is going to be very different, but if you see, there is some other kind of research work which is already going in these styles, right? So again, I'm repeating, these styles are not new styles, but we are using it now, correct? So if you see transfer learning, maximum work has been done on transfer learning. Apart from that, there is a steady work which is still getting done with supervised learning. However, along with that, active learning is the one where there is lots of work which is happening, right? Then there is ensemble learning where there is lots of work which is happening. Or reinforcement learning, if you see, there is steady growth in the number of research papers that has been published where reinforcement learning has been used. Even co-learning is also slowly improving, right? So there are all these machine learning styles on which people are working, where people are applying it to solve their research problems. And of course the new graph will give us more I think insights now, that among these, which learning style is in 2025, which machine learning style is more prominent. So now, delving very deep into these machine learning styles, we have to understand that what kind of human learning style is actually mapping to what kind of machine learning style. Using this, it will become very easy for all of you to understand that when to use which learning style when we are actually solving some real life problem statement. Okay, so if I'm learning from very few examples, again the same condition, that if my exam is tomorrow and today I want to read the entire book and I want to study the entire book, what I would do is, for every concept I will read just 2 to 3 lines. I will see some few examples so that I can understand what is that concept. So the same what I would say, the same pattern of learning is followed here, and it is known as few shot learning. So these are actually the easiest definitions or easiest way I can explain to all of you, just to remember that when to use which style. Then another is generalizing to new situations. That entirely unseen scenario is there, and I do not have any idea that what or how I should behave in this new situation, but based on my previous experiences of various situations, I will also find out a way in this. Correct. In very simple example can be, if I'm traveling to abroad for the first time and I want to book a taxi. Okay, now I have never been to US, I do not know their taxi systems at all. Correct. But in India I know how to book a taxi. So based on that experience, even in this new situations, I would automatically learn, or I would automatically adopt to that how to book a taxi in US as well. So that is known as a zero shot learning, where my previous training in that situation is not being done, but in similar situation the training has been done, and based on that I will adopt, and I will complete the task in this situation as well. Then next is reinforcement learning, which is nothing but learning by doing or trial and error. So in real life, if I'm learning any new sports, for example, so what will I do? Every day I will go on the sports ground. Every day I will play that sport. Every day I will realize that I am doing such mistakes, and my trainer is there who is giving me the feedback, and based on that every day I am improving, right? So in reinforcement learning, so that playground is nothing but my environment. Okay, and in that environment there are multiple players which are available, and every time based on what others are doing, I also have to develop my strategy to play that game. Okay, and my ultimate thing is that I will learn football very well and I will do some goals. But it will not happen in one day. Every day I have to go there, reinforce learning will keep on happening. Every day I will get penalized for doing wrong moves, and every day I will also get rewards for doing the right moves, and in that the environment is set up on that ground. Okay, so generally reinforcement learning is mainly used when we want to teach robots for doing various kind of task, right? So to teach them also, using reinforcement learning, we can develop an environment. In that there are multiple RL agents. The work of those agents is to keep learning from the environment, and they get penalized if they are doing wrong, and they get rewards if they are doing right. This is the main core of a reinforcement learning. So all of you would also know that in which problem statement I can use reinforcement learning. Then next is multitask learning, where what do I do is multiple tasks I do parallelly, and finally then I have a common outcome. So an example for this is that to pass a BTech semester, there are 6 subjects. All the 6 subjects I am learning parallelly. Ultimately for every subject I am getting some outcome. That outcome is collated. Based on that, either I'm pass or I'm fail. Okay, that is known as multitask learning. And one more is self-supervised learning. Self-supervised learning is very massively used nowadays, where the AIML model itself will direct its own learning curve without any explicit labels. Okay, from the unlabeled data itself, but in a self supervised manner, it will keep learning from the unlabeled data, and then also keep understanding the labels of those data as well, right? So that is known as self supervised learning. Then we have a meta learning, which I just explained few slides back, where if I know one task, then adopting the next new task will become easier. In the similar way, if my AIML model knows how to identify the fake news, fake political news, then it will be easy for me to teach my AIML model how to identify fake beauty news as well, right? So learning from the meta features is known as meta learning. Then there is active learning, where there are experts which are available, and the model can ask multiple questions to the feedback provider, and based on that actively it will keep on learning. Active learning is similar to reinforcement learning as well. Then we have a collaborative learning, and last one is the federated learning. In collaborative learning, we make sure that the models are learning in a collaborative manner, so that to complete one task, maybe there are two models who are collaborating and learning together, understanding the context, and finally based on that we are completing the task. And federated learning is something which generally we use in the distributed teamwork. If I have a business in Pune, I have a business in Bombay, I have a business in Chennai, then in that case, I have all my teams which are, sitting at different locations, but I'm doing my decision making based on the data or based on the insights which I have from Pune team, I will have from Bombay team, I will have from Chennai team, right? So in this way, a federated learning will happen from various locations. So these machine learning styles which are came into the picture have not came into the picture from somewhere from air. They are actually to mimic human intelligence, and based on how we react in various situations, how we learn in various situations and change our decision making strategy, the same has been implemented in on all these machine learning styles as well. So that's the reason why for every style there is some or the other real life scenario which is available, and this will make it very easy for all of you to understand the difference between all these styles, and also to understand that when we have to apply which kind of style. So if you see the idea of different machine learning, okay, multitask learning is about shared knowledge which is transferred from multiple tasks at one point of time. Few shot learning means learning from very few samples. Zero shot is to generalize without any prior training, so to generalize without examples, only based on experience. Active learning is that for selective what I would say for selective problems, asking the right kind of question to the user or to the AI architect, and based on that learning in the next points. Or co-learning is collaborative knowledge sharing, supervised learning is self-guided supervision, and reinforcement learning is learning via rewards. Okay, now how learning actually happens in these different machine learning styles, if we see, so few shot learning, they learn from few examples. Zero shot learning, no specific that way a data is required, so generally our GPT, if they are in the instruction mode directly, they are using zero shot learning there. Reinforcement learning, they learn from the environment. Multitask learning, they learn by doing multiple tasks together, right? So they're generally multitask learning performs very well in multimodal applications as well. So for example, from my video, I want to analyze the kind of mental state in which I am, right? So that mental state will depend on two things. It will depend on my facial emotions also, which is nothing but the images and the video, and it will also depend on the audio voice, where are there any ups and downs in that voice, and that can also give an idea about my emotional state, correct? So in this case, I will have one AI model which will keep analyzing my facial emotions. I will have another AI model which will keep analyzing my audio voice, and based on that, both of them together will give me the output as whether I'm happy, whether I'm sad, whether I'm anxious, what it is, right? So in this case, this is an audio modality, which is sound modality, and the image modality which I'm using parallelly together, right? Then co-learning, meta learning is again learning across the task. Co-learning we have already seen, so quickly I will skip this. Now the next very important question is also about that when to use which style. Now this is directly related to the kind of problem which all of you would be solving using AI, or are currently doing your PhD and trying to solve it using AI. So few shot learning you can use when you have very little data per class or per task which is available in your data set, right? Or if there is an imbalance in the data set, then also you can use few shot learning, or very limited data set is available, in that case also you can use few shot learning, right? Then we have zero shot learning, where if I don't have any avenues to retrain my model, then in that case I can use zero shot learning, where it will generally generalize to new classes or tasks based on the prior experience. Reinforcement learning, I have already told that generally in robotics plus AI kind of applications, definitely reinforcement learning can be, very, very good, a learning style which is available. Multitask learning, if you have related task and want to train a shared model. So the example which I have given, I want to analyze the emotions which are there based on the video. So, but that video is related to me, right? My voice is getting analyzed, and my facial emotions are also getting analyzed. So when you have related tasks to analyze, then multitask learning is very, very good. Then next we have self supervised learning. So if you have a massive amount of unlabeled data, okay, and then in that case definitely there are ready made models which are available for self supervised learning that can be used, where it will learn from that unlabeled data in a supervised manner, right? Then there is co-learning, where I have a distributed source, or the data is coming from distributed sources or distributed learners, and I want to also have a privacy constraint onto it. So especially banking applications, if I'm using AI, or any defense applications I'm using AI, where again there are distributed sources of data which are coming, but a very good privacy I want to maintain, because the data is very confidential. Or in any telemedicine applications as well. So we have all the apps nowadays which are telemedicine applications, but again all the users of that app is from various locations, and also I want to maintain the privacy of those users. I can use co-learning. Meta learning, when you need a model to learn new task very quickly with few samples, right? So I know football, I want to learn basketball, definitely I will learn it very quickly, right? So then in that case you can use meta learning. And then active learning is something where labeling the data is very expensive, but still my model wants to learn. So the model will ask very critical tricky questions, and based on that it will do its learning, okay, instead of learning from the labeled data. Then we can use active learning. So I hope all of you are also understanding the insights, and also trying to relate to what all of you are currently trying to solve in your domains. Because I have understood from from the Sanjay Ghodawat team that here the participants are from civil engineering also, mechanical also, or it is from chemical also, or electronics also. So in this case, definitely when you will be working in adopting AI for your domain problem statements, all of you will be facing these challenges. And in that case, all of you can explore that instead of using machine learning, or instead of using traditional supervised machine learning, what are the different avenues which I can use? Yeah, so just an example of meta learning. So if you see, I have a meta test data set and I have a meta train data set. Okay. Not necessarily that they are trained on one task only. However, they are trained on multiple immense amount of classes, and slowly I will fine tune them for the test data set on which I want to apply my learnings, right? This is one example. Another example which I have given to you, that if I have trained my model for fake political news, I want to now train them for fake beauty news. Then the meta features or meta learning data set which I have used for fake political news can also be used, and then the model can be implemented for fake beauty news as well, right? So again, some examples of it, where I have my base classes which are there, and I'm doing pre-trained models which I'm using, and at the same time I'm copying these layers, right? So this is metadata which is getting transferred for my next task, whereas my next task is not exactly similar to my previous task, but some similarity or some common features are there, and still I can use the same model which has been not only trained for this data set but has also got the learnings from my previous data set, right? So metadata I have transferred, and I have fine tuned my model onto the new features as well, right? Yeah, so it is just an architecture of meta learning. So I have a training data set. This is the way the metadata is stored. I have a meta database. From that I'm training my meta learner, and for new data set also I'm using the meta learner from my training data set, which is a different data set as well, and based on that I can do my predictions. Now, next is the example of multitask learning. So in multitask, we have just seen that there are multiple tasks which are executed parallelly. So for example, there is an input data, okay, but that input data, I am not training it in one go with one AI model. For every task, I am training a different AI model. From them, from all those tasks, I am having my output layer, and from there I am doing my prediction. So there is a difference between the way meta learning is happening and the way multitask learning is happening, right? Here I still have only one model which is I'm training, right? But to that model I'm transferring the knowledge from my previous model as well, correct? But here in multitask learning I do not have any previous model. The existing task only has been divided into multiple tasks. For every task there is a separate AI model which I'm training, and ultimately I'm combining their outputs and giving the prediction. That is the difference between meta learning and multitask learning. Now, self-supervised learning. In self-supervised learning, generally what we do is I have some source labeled input data, whereas my target unlabeled input data also I have, which is huge in number. So again, I will use a pre-trained model. I will do a knowledge transfer, and to my target model, then I will give a unlabeled input data, which my this target model will learn that the prediction of the target task has been done. So some amount of source labeled input data I have given, however my main input data is completely unlabeled. So then in this case, my this target model will actually self-learn from the unlabeled input data and also from my source labeled input data, and it will do the knowledge transfer and give me the prediction of the target task. Okay, so in this case, see, the first portion is actually supervised because there is a sourced labeled input data, and the second portion is completely unsupervised, right? But learning this unsupervised data from the previous supervised data, so it is known as self supervised learning. Okay, now next we will see, so this is just an example again where a smaller labeled data set was available, and then there was some unlabeled data set also which was available, but ultimately we have done the training on this unlabeled data set, and then the transfer learning has been done on a smaller labeled data set as well. So self-supervised learning is also very similar to domain adaptation or transfer learning, which we do between various domains as well, or between connected domains as well. Connected domains means what? When I was trying to find out fake news from political and fake news from beauty, my basic background data remains the same, which is data in the text format. So it is there mainly transfer learning and domain adaptation is generally used. Now next we will see zero shot learning. So the ones which we have seen, the idea was that if I'm not pre-trained into those what I would say scenarios, but now I have to give the prediction in something which is completely unknown and the model is not completely trained onto it. So what we do in this case is mainly I'm learning this classifier using zero shot learning, training this classifier using zero shot learning. So I have unseen class attributes, Based on that, I have unseen image features. So these features are also given to the classifier, and some experience I have of similar or a non-similar task, but those seen class features are also embedded into my uh, model, and based on that I'm giving class probability. So if you all remember the example which I have given, that I want to book a taxi in US, which is my unseen completely scenario, but I know what is the process of booking the cab, right? So this is nothing but my seen class image features. So based on that, my model will learn in this unseen scenario as well. So that is known as zero shot learning, where from the unseen scenario there is no learning which is happening. What I'm doing is, whatever previous learning I have done, I am implementing those insights in learning in familiar situations as well, or scenarios as well. So this is known as zero shot learning. The next is, yes, one more example of zero shot learning is what we have seen, where the model knows how to identify horse, it knows how to identify tiger, it knows how to identify panda, right? So it knows how is the horse shape, how are the stripes, how are the black and white colored animals, right? And based on this, model has learned how to identify a zebra, for which the model was not trained. It knows how to identify stripes. It knows how to identify the shape of an horse, right? And it knows how to identify an animal which is in black and white color. So based on this previous training which the model had, the model was able to, also identify and get trained on identifying a zebra as well. That zebra is an animal because maximum of the attributes of an animal which it has been trained, this new picture is also having those similar what I would say features, right? So this is known as zero shot learning. Next is few shot or one shot or zero shot learning. A very good example is given here, where if I'm using one picture of a dog, and if I say who am I, and if I implement zero shot learning onto it, so in first run my model will be able to identify it is an animal. Then in second iteration it will be able to identify this is a dog, and in third time it will be able to identify this is a standing dog, right? May or may not be, it will be able to identify the breed of that dog. So this will happen in zero shot learning. Okay, but if I'm using one shot or few shot learning, where if I'm learning from one example only, that this is the picture of a German shepherd, and then I'm asking who am I, then my model is able to identify based on these feature similarities that this is a German shepherd, even in first go itself. Okay, if I'm doing few shot learning, in few shot we have seen that few examples the model can be trained with. So I have given an example of German shepherd, I have given an example of husky, I have given an example of one more type of dog, and then if I asked who am I, the model will be able to identify very nicely with the exact type of the dog which is there. So generally few shot or one shot, they also perform very well, right? So these are just example of few shots only. Okay. So I hope all of you have understood the difference between multitask, meta learning, then what we have seen, self-supervised learning, then zero shot learning, few shot learning, one shot learning. Okay, once you understand these fundamental differences, it will become very easy for all of you to next time take the decision that no, instead of unsupervised learning, maybe if my data set is having this kind of complexity and this kind of labels and this kind of data availability, better I should use few shot learning, right? So those insights will be very, very useful for all of you, right? Co-learning or federated learning. So what do we do? At local level, I will have multiple models, right? Now this is very different than your multitask learning. In multitask learning, what happens, there is no centralized model available. It is just like that each task is getting divided into smaller sub AI models, and all of them are working at the local level. Whereas in your co-learning or in your federated learning, we have multiple local models which are available. However, I also need to have a global model where the insights from my local model should also go, and this is known as co-learning or federated learning. Okay, next is how to achieve higher accuracy in each style, because not only I can apply a style, but at the same time I should also know that which machine learning style can give me good results in which scenario. Okay, so if you take few short learning, then in that case, if it is trained on diverse tasks and good support but few examples, but good examples which is covering the diversity of the problem is given, then few short learning can give you a better accuracy. In zero shot learning, if the connectivity between the task is there, right, and those tasks or classes are well defined before, then it will give a very good learning, which is even in zero shot. In reinforcement learning, if in which situations I'm going to give the reward to my model, in which situations I'm going to give penalty to my model, in which situations or how my environment I'm going to design, and what learning is expected, if I know this very well, then reinforcement learning will also give you very good output. Then we have multitask learning, where if I the tasks are related to each other, they are not completely two different tasks, then multitask learning can give you very good insights. In self supervised learning, when we used it for pre training followed by a fine tuning on label data, then it can give good results. In case of meta, again, it depends upon which meta features we are transferring to which model. That definitely the task should be related, then meta learning can give you good results, right? And in active learning, what queries we are asking actually to the user will matter the lot, because those queries should ensure that my learning should happen very properly. Then domain wise best fit styles which are available. So in healthcare, if you see, so few shot or super shot few shot or self supervised learning or federated are giving good results. In healthcare also, for peculiar problem statements, we have label data which is available, right? Because we have doctors or we have the support staff which can help to annotate that data very properly. So definitely there are chances of good annotated label data set which are available. So that's the reason why, if it is available, definitely supervised machine learning will give you very good results. Or instead of that, if there are few samples which are annotated, right? So for example, I have 10,000 patients ka x-ray, in which at least 500 samples are annotated of such patients who had some kind of lung disease. So with that few samples also, I'll be able to apply few shot learning and get very good accuracy. Then in finance domain, if you see, majorly after supervised, nowadays the one which is maximally used, if you are analyzing the finance data, it is reinforcement learning and meta learning, which are very very widely used. And federated, why? Because finance, of course, it is related to banking, it is related to insurance, where again there is multiple location the data is getting generated, and we want to analyze that in one go. So that's the reason why federated learning is also very nicely applicable in the finance domain. Then we have autonomous systems. In that, reinforcement, I would say, and multitask is very nicely used, because again, very dynamic decisions have to be taken in autonomous systems. So that's the reason why RL will perform very very well here. Then in retail or e-commerce, where multi-factor decision making has to be done, right? In that case, again, meta and multitask will perform very very well, and even co-learning can perform very very well. Okay, then in education sector, we say meta, RL, few shot is giving good results. In cyber security, unsupervised, few shot and federated are the ones which are giving better results, right? So if you are working in any of these domains, based on the domains also, we can see or we can decide that which kind of accuracy the kind of different machine learning styles can achieve. Okay, this is a document. Maybe this document I will share with all of you via the Ghodavat team, where have taken some examples of what kind of machine learning style will be applicable to solve what kind of problem statement in a particular domain. So in finance, what it can solve; in healthcare, what it can solve, right? So if time permits, I will show you the document. Otherwise, I think we can quickly move to the last section of this presentation, that implementation of these machine learning styles has to be done in a very responsible manner. Why? Because these AI/ML based solutions which we are implementing for very critical problem statements also has to be trustworthy, right? They also have to give us the explanations for the outcome which those AML models has to done. So in this case, when we are implementing supervised machine learning based problem statements, at that point of time also we are expecting that they should be secure, they should be trustworthy, they should give me the reasons. So when we are applying these various machine learning styles, at that point of time also the responsible AI angle has to be kept in the loop. So if you see how do we define, for example, a responsible AI system. So it is like data integrity which we have to maintain, so that there is a consistency in the data wherever we are using. If the data is updating, the data is also getting updated at all the data points, right? This is especially important if we are implementing federated learning, because in federated learning we are implementing a distributed network. Then there are transparency measures where explainable AI came into the picture. Then there is bias mitigation. Why? Because even though I have a very small data and I am implementing few short learning, but is that data bias free? That I have to check. Otherwise, even my few short learning will also be biased towards certain samples which I am giving, or ethical guidelines as well, right? So to um, to curb or to tackle the problem of responsible AI. So there are four pillars of responsible AI. Mainly transparency we have to maintain, bias we have to take care of, who will be accountable for certain. So if I'm using reinforcement learning and if I'm teaching my RL agents how to behave in a distress situation, then in this case, if there is some training which has gone wrong and my robots have not behaved the way they should have behaved in that distress situation, then who will be accountable for that? And then the fairness, right? So the fairness metrics also needs to be considered. So whenever we are implementing any machine learning style as well, not only we have to see that what kind of data it is, what kind of problem I'm solving, and what kind of machine learning style is applicable for this, but at the same time I also need to see that whether my this machine learning style is going to help me to develop a responsible solution which is based on AI for a critical problem statement or not, right? So so these are various machine learning styles, and 3 to 4 very important points when it comes to responsible AI. So if it is a supervised learning, then there can be a bias in the labeled data, right? Explainability generally is good because already it is a labeled data, so that's the reason why it do not give very haphazardly different predictions, right? Privacy and security of these models is moderate, whereas robustness is not that great. If I even change one input in my data set, I may also entirely attack the AML model and change the entire predictions, right? And data challenges are definitely there. So in this way, each and every machine learning style will have challenges from the responsible AI perspective. Okay, so this can also be a topic of research, that if I'm implementing, for example, meta learning in the healthcare domain, so how my meta learning framework should be, so that it will be able to defend all the challenges which are related to responsible AI. So again, a food for thought for all of you. And with this, I will be finishing my presentation. And I hope I am well within the time so that we can get little time for, interacting with each other as well, right?
Thank you, ma'am. It was such a wonderful and insightful session. I also thanks all the participants for the active involvement. I may request all the participants if they have any queries regarding the session, they will ask.
Ma'am?
Hello.
Yeah, yes, ma'am. My question is, what is the difference between deep learning and meta learning?
Sir, meta learning is a type of deep learning algorithm only. So in deep learning also, we generally learn, from a very complex data, and if using the unlabeled data itself. So if you say I'm implementing deep learning, which, you are saying I'm implementing CNN, I'm implementing RNN. So that implementation can be done in the meta learning framework. So your actual neural network will remain the same, which is your deep neural network, right? But that deep neural network will also learn from the weights and biases of another model, which is nothing but your meta learner model. That is the difference.
Hello, ma'am. Good evening.
Hello, sir.
Yeah, it was a nice and informative session. I
Thank you so
have one
much.
query, ma'am.
Yeah.
We'll be doing some experimental research.
Hmm.
So we'll be having some data.
Hmm.
Same thing, we'll be doing simulation
Hmm.
analysis in using some analysis software. By feeding
Hmm.
this in data, we can also do simulation, right? We'll
Hmm.
be able to predict some other new data. So how that
Hmm.
simulation is different from this machine learning? Because machine learning also trained by known data, then it is
Hmm.
also able to predict something.
Yes,
So
sir.
can
So
you?
the way you are learning in simulations, it is very similar to reinforcement learning.
Okay, then how machine
Right.
learning is different
But
from this
not
simulation studies?
right, but not for every study you can simulate that environment, because there are certain simulation tools which are available which will help you to simulate only a certain problem statement. Whereas, for example, if I want to do any analysis from the finance domain and I want to train an RL agent onto it, I'll be able to do it because I do not have any other simulation tool as such to do the finance research.
Okay, so machine learning
Right?
is more flexible than simulation, you're saying.
Yes, definitely it is. Generally, simulations is available for networking. So in computer networks, there are lots of simulation tools which are available, right?
Okay.
But not necessarily for every kind of problem statement, there are simulation tools which are available. But still, if I want to do simulation learning, then reinforcement learning is the solution for that.
Okay, actually, I am from mechanical department background.
Yes. Even in your background, there are lots of simulation tools which are available.
Yeah, we will be using ANSYS, COMSOL, so many different
Yes,
simulations, fluid,
yes, yes.
structural
But
and
sir,
fluid flow
yeah,
simulations.
true,
Whether we
true.
can implement for this machine learning for the fluid flow problems or heat
Yes,
transfer problems, ma'am, is it possible?
yes. It is possible, sir. It is possible. There are many, various now libraries which are available in MATLAB, which will help you to apply machine learning algorithms for even mechanical problem statements as well. And then if
Okay,
you want to move further, then for example, I have two of my PhD students who are working in industry 4.0 plus AI only, where what they have done is, for the given machine, they have finded out faults based on multi-sensor data, and for that they have applied deep learning and multitask learning together. So these
okay,
are the
they
areas, or these are the problem statements where AIML without simulation or without even RL we have implemented. So it depends upon the problem statement and the data and the kind of training that you have to do. We can decide the combination of these learning styles along with deep learning, how we have to implement.
okay. What they use,
Hello.
madam, meta learning and one more thing, what they use it?
No, they have. So she has implemented first the deep learning models which were available, and then she has also developed a meta learning based framework for doing the fault diagnosis.
Whether that outcomes are matching with the simulation kind of outcomes?
No, but she didn't use any simulation tools, sir.
Yeah,
For
she did
doing
not use it,
fault
but
diagnosis. Yeah,
We
for
did not
doing
use it,
fault
but
diagnosis, there are no. So what she has done is she has done fault diagnosis on bearing machine.
yeah, I understood.
Yeah,
Ball bearings. Every
ball
machine is
bearing
having
machine.
bearings.
She has done it
Yes.
based on sensors. So for that, she has not done benchmarking with some simulation tools because it was not about the design of that tool. It was
Okay.
about,
Madam, last one more query
yeah.
before.
આને કીધું ને યુ એટલે તિમિલાય મતલબ સિમિલાય જ ના
Hello.
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 Good evening, ma'am.
Ma'am.
I have a question.
Yes.
May I ask?
Yeah,
Earlier,
yeah.
you have shown a slide where there is a picture of some birds, zero shot learning. I think that was where the result was have to be predetermined by the AI, right?
No, it is not about predetermining. So, for example, the model has been trained for finding out a particular kind of birds. So, all the crows and all the sparrows, they are well versed with. The model is trained on finding out whether this is a crow or a sparrow. But then, if for example, now my model wants to learn how to identify a parrot, then in that case the previous learning will also be helpful, and with that the new learnings the model will do of identifying the parrot, and then the predictions will be made that either this is crow or a parrot or a sparrow.
Okay, ma'am, one more question. Another slide which I have shown the dogs, breeds of dogs. Moodhole, something like
Yes.
that was a dog.
So few short
But the
and
AI question,
zero short learning. Yeah.
zero shot and few shot learning.
Yes.
The AI was not determining that the new breed is what. So the dog is there, is
No, no.
identified, but the
So
breed of dog.
right. So in case of zero shot learning, the AI was not able to determine the breed of that dog. Why? Because उसका previous training कुछ हुआ ही नहीं है on identifying the dogs.
Okay.
Right? The previous training has been done based on identifying some kind of animal, but not the dog. But since it knows how to identify some animals, it has also taken the insights and identified that this is an animal which is named as dog, but not the breed was identified because it has not been trained on those breed. Then in one shot, what happened? I gave training on one image. Based on
Okay.
that one image, still it was able to identify that this is this type of dog. But if I could have given another image, the model would have failed and it would not be able to identify the type of the dog. It would have identified that this is the dog. Then
Okay,
in
in
few
few short learning, it is so also.
No, in few short learning, what is happening? I'm giving multiple examples, but very few examples. So I have given example of dog A, dog B, dog C. So my model has at least little information about all these types of dogs, and then it will be able to, identify even the breed of that dog, which is not possible by zero shot.
Okay, okay. Thank you, ma'am.
Thank you.
Ma'am, I was asking one more question.
Yes, sir. Yes, sir.
Yeah. Actually, my research area is passive cooling of buildings. So where we'll be trying to cool the building using passive methods, kind of heat transfer problem. So what is the kind of method it is suitable to do research in that area to apply these models? Which model will be fitting that? Any suggestion on that?
Sir, we have to see the data set which you are collecting and what are the features that you are capturing and what is the kind of outcome that you are expecting, right? In your case, if that data is only numbers which you are capturing because it is going to be the temperature data,
Yes,
right?
yes.
Correct. And then it can be humidity of the building and what is
Yeah,
the
mostly it
temperature,
will be numbers only, ma'am. Numbers,
right? And
numerical
then
data.
comes the air pressure in that building because that will also affect the level of cooling that the building can have, right?
Yes,
So
yes.
then in this case, maybe a time series analysis will be better for you, and in that then you can choose uh, mm, maybe multitask will not fit into your problem statement because that way the tasks are not too many. It is just basic task which you want to do, but maybe a meta learning is something which you may try to apply, or instead of meta I would say self supervised learning will be more better because in this case also, if the features are available, the numbers are available for those features, but if they are not labeled data, then in this case, instead of meta or multitask, self-supervised learning will give you a better results.
Okay, supervised learning, and one more thing you mentioned in the initial. What is that, ma'am?
No, sir. It's time series analytics you can implement. I
Okay,
think maximum of your work will be done using time series itself. You don't need even the machine learning styles as well, because in this case, your maximum focus is on gathering that data and creating insights from that, and then AI/ML can come into your last objective.
No, madam. Actually, I will train with known data. Then I want to predict which is not known, which is not performed any experimentation. So that is
Okay.
possible with ML.
Yes, it will be possible, sir.
Hello,
So that is
ma'am.
kind of fine.
Yes.
Supervised will be
Self-supervised
suitable,
learning
ma'am.
or even few shot learning you can try, sir, because you
Okay, ma'am.
already
Thank
have
you.
few samples which are labeled.
Yes, yes, yes.
Yeah.
I will
Okay.
definitely approach through email, ma'am. Thank you very much for your
Yeah. Thank you, sir.
suggestions.
Yeah.
Hello, ma'am.
Hello, sir.
Hello, I
Hello.
am Dr. Manish. So far we were
Yes.
discussing regarding the modeling and the AI. So for my knowledge, the for any modeling, it will require mathematical model first in the mechanical stream. But for any AI tool, it requires a lot of data
Hmm.
to generate. So both are, I can't say the similar.
Hmm. Okay.
Regard for any modeling simulation, we have to do first mathematical model, then only it will work or predict the things.
Yes, sir. So for mechanical background, of course, you have to do the mathematical modeling, and based on that, you have to decide the kind of, machine learning model that you can use. Maximally, what is happening in mechanical also, there is a fixed stream of data which comes. Okay, so then in that case, maybe if you do till deep learning, that will be enough. But for problem statements which are related to finance, problem statements which are related to NLP or social media, or problem statement related to climate change, these are the areas where there is huge explosion of data and labeling is not possible, where then all these different kind of machine learning styles are available which we can use.
Thank you,
So
everyone.
yeah.
Okay, thank you, ma'am.
Okay, thank you so much. Thank you for being great audience as well. Very nice questions. Thank you so much.
Okay. The feedback link will be shared in a chat, also in a WhatsApp group. Hello.
Hello. I have one question, ma'am.
Hello.
Hello.
The notes regarding this session will be shared on the Atal portal, and also the link will be shared on a WhatsApp group. Thank you, all the participants.
Ma'am, feedback link
Will be shared on WhatsApp group, ma'am.
later after leaving the meeting.
Feedback link is already shared in chat box. You will check.
Okay. Okay. Okay.
Yes.